Here's another little inverter that I have. This is basically an early take on a power bank, and it takes these Black & Decker VPX batteries. That's an aftermarket battery. The original ones look like this. And there were a whole bunch of tools that Black & Decker made that worked with these batteries. Over here I got this small drill. The batteries are 7 volts, I believe. Yeah. Let's see. Yep, 7 volts each. This drill right here takes 2 of them, so it's 14 volts. And then I got another, like a power screwdriver right here. And I even have a reciprocating saw. There are also tire pumps and flashlight and a few other things, but this video we're going to focus on this. Puts out 120 volts AC right there, and then you got a USB port. Hold this down to turn it on, and the battery slides in there. So we'll go ahead and test this out. I have this 3-prong adapter thing so we can put the kilowatt meter into it, and I'll test it with the Fluke 325 and I'll plug these little fans into it because that's pretty much all this thing is going to be able to run. There are power ratings. It can put out a max of 8 watts out of the 120 volt outlet, and then 350 milliamps out of the USB port, which really today isn't very good because phones require a lot more than that to charge. But this thing is pretty old, and I think it's still pretty cool. I have some newer power banks that are much better at charging phones than this one is, but got a couple of newer power banks here. This is a 42,800 milliamp hour power bank, and this one is a 10,000 milliamp hour power bank. And this one has a regular USB-A port and a USB-C port. If you want to charge this thing back up, you plug in the USB-C. You plug the charging cable into the USB-C port. I believe this is actually capable of charging 2 devices at one time. If you have something that can hook up to the USB-C and USB-A port. So there's that one. Nice and durable. It's got a rugged rubber case on it, and you probably can't see the light, but it shows how much charge it has. And then there's this one, which also has solar charging, but it doesn't really charge it very fast. It's got a flashlight on it, and let's see if I can open this. It's got 2 USB-A out charging ports, and then to charge the power bank itself, use the micro USB port. So, yep, and we can see it's fully charged right now. Okay, I put the battery in. Oh, it just popped out. There we go, now it's in all the way. There are still products like this nowadays. You got obviously the big ones that are called power stations, and those things are, 1,000 watts and above, but there are some power banks that have 120 volt outputs as well as the USB port. So I'm going to go ahead and turn it on. Just hold that down until the green light comes on, and now it's ready to be used. Alright, so there's the output voltage from the 120 volt outlet on it. And of course, this is not a pure sine wave inverter by any means. You can see with the kilowatt meter plugged in, it's saying 0.0 volts, so yeah, this thing definitely does not have a clean output. Let's see. And it's saying we're getting direct current, so I mean, obviously that's not true, because I'll run a fan on it in just a second and you'll see that, it's definitely not direct current, but yeah, we are not getting an accurate reading at all with the kilowatt meter, and that's probably because this is not a true RMS. I tried hooking that little Lakewood up to it and it just cut off as soon as I turned it on, but this one seems to be working. This one has a C-frame motor. So here we go, here's on. And it is powering it. I'm going to try and see if you can hear the humming from the motor. Now I have the fan plugged in through the kilowatt meter going into the Black & Decker power bank thing. And I'll turn to amps and see what we're getting. .3, it's bouncing around a lot. Let's see what we're getting for watts. Still not giving us an accurate frequency rating, and now that there's a load on it, we are getting a voltage reading that's actually somewhat accurate. Turn the fan off, it goes back down to 0, which is obviously not true. So that's interesting. And now we'll run the fan off of line power. Here is amperage. It's running faster now. And we're drawing less power. Now I don't know if the power draw rating on this was accurate when it was plugged into that. It probably wasn't. But yeah, that's what we're getting now. See if you can hear the motor hum. The motor is a lot quieter, doesn't hum as loud. This probably has a square wave output. And I got the original chargers for these batteries. Now I had, several of these original ones, but they failed after a while, and I bought some replacements on Amazon. These are called Power Extra. And it doesn't seem like they have as much capacity as the original ones did, but the nice thing about these is you can actually pop these open and rebuild them with new cells. As you see, they kind of clip together. So these are 7 volts, like I said. It's not. I don't see how many milliamps it is. Milliamp hours. Yeah, it doesn't say. I wonder if these do. Yeah, these are 2,000 milliamp hour batteries, at least according to that. And these are lithium-ion batteries.